put the heading alkynes. Alkynes. Generally, this alkynes generally were called as acetylenes because ethine. This is ethine. How can we say this is ethine? Eth plus ine. Ethine. This is root word. This is primary suffix. So common name generally we are called acetylene. This is acetylene. Acetylene. This hydrogen, this carbon is sp carbon, so more electronegative carbon. So this hydrogen is having the acidic nature. Acidic hydrogen. Acidic hydrogen. Sp means linear, that already we know. So carbon is 6 nana, 1s2, 2s2, 2p2, right? This is which electronic configuration? Ground state electronic configuration. In case of excited state, what exactly happens? One of the electrons jumping to here. So undergoes sp hybridization. Sp. Sp means now one s orbital, one p orbital mixing, we'll get two p orbitals now. Like this, two sp orbitals. Carbon is having one carbon and one more carbon, the same thing, and two hydrogens. End-end overlapping is takes place, so we'll get C, H. Then we'll get the two pi bonds, two p orbitals are there. This two p orbital undergoes right sidewise overlapping. Sidewise overlapping will get two pi bonds. In this case, one is sigma bond, two are pi bonds. One is in triple bond, one is sigma bond, two are pi bonds. Write it down. The nomenclature part already we know, right? CH3, C triple bond, CH. Write the nomenclature. First one, propyne. Here is but2-ine. But1-ine also is possible. That's the reason you can take the but2-ine. In this case, 1, 2, 3, 4, 5, 6. X, right? 1, 4 diine. X 1, 4 diine. Like n number of ions are coming, diine, triine, tetraine, pentaine, like that we have to use. Write it down. When double bond and triple bond both are coming, what we need to do? So double bond and one side is triple bond. So where we need to start? Double bond or triple bond? Triple bond, is it right or wrong? Hello? This is wrong. When double bond and triple bond both are coming, so we need to give the priority for double bond. Write it down. CH2. A lot of people are thinking triple bond seems to be bigger, right? No. So according to priority, we need to give the order. Pent. 1 in 4 ion. 10 to 1 in 4 ion. Write it down. And double bond and triple bond. But in this case, double bond and triple bond is both are there. So whom we need to give the priority? In this case, triple bond, because double bond is coming in the second position. Right? Pent. Right? 1 ion, 3. Next, directly I'm preparations now. Preparations of alkyne. When calcium carbide, CaC2, right, on hydrolysis, we'll get acetylene, C2H2. Write it down. Calcium carbide and hydrolysis. Beryllium carbide and magnesium carbide cases, we got, methane, we prepared carbides. So from vicinal or geminal dihalides. For example, next to CH2Br, CHBr, for example, CH3. Right? This is geminal. Geminal means same carbon. Vicinal means adjacent, like this. If bromine are coming the same, those were called as geminal. If adjacent, we are called as vicinal dihalides. When we are using the alcoholic KOH, what is the use of alcoholic KOH? Dehydrohalogenation takes place. Dehydrohalogenation. So here is, for example, CH2Br, double bond, so here, so in this case, vinyl bromide, this is having the resonance. That alcoholic KOH strength is not sufficient. So that's the reason we are using NaNH2. This is strong dehydrohalogenating agent, so we'll get triple bond like this. Otherwise, directly we can use NaNH2 strongly. Come on, write it down. So directly I'm using NaNH2. NaNH2 in presence of liquid ammonia. So we'll get acetylene here. Anything we can take now. So alkynes we will get. So we can prepare alkynes from coal-based electrolysis. I already explained coal-based electrolysis. How many of you know coal-based electrolysis? Yeah. Next now. So from lower alkynes to higher alkynes also we can prepare. For example, try to understand CH3C triple bond CH. If you are using NaNH2. So what exactly happens? CH3C triple bond C minus Na plus. Right? Here, if you are using the RX, alkyl halide, R means either anything we can take. So for example, I'm just taking here CH3Cl, imagine. So what exactly product? CH3, C triple bond, CH3 will get common. If you are taking the ethyl chloride, ethyl group will be substituted. If you are taking the propyl chloride, propyl group will be substituted. From lower alkynes to from lower alkynes to higher alkynes. From lower alkynes to higher alkynes. Coal base electrolysis already we discussed. Right, CH triple bond, sodium malate, H2O, electrolysis, what exactly happens? CH triple bond CH plus CO2 plus NaOH plus hydrogen. This is at anode. You're at cathode. I explained the mechanism also, right? Two Na plus now. At anode is positive charge. So here is CH, triple bond CH, CO minus. At anode, which reactions are takes place now? Oxidation. I already explained this, right? Oxidation. So here is next homolytic cleavage which takes place. 2 moles of CO2, 2 moles of CO2, and acetylene is forming like this. At cathode, which reactions are takes place now? Negative reduction is takes place. So H2O plus 2 electrons, 2OH minus plus H2 plus 2OH minus plus 2 Na plus gives rise to 2 NaOH. Hydrogen and NaOH are present at cathode. Next, from chloroform. So from chloroform also we can, what is chloroform? CHCl3. Can I write like this? CHCl3, chloroform. 6 Ag. 6 moles of Ag, ClCl CH. This is going like this. 6 moles of AgCl is going out. So CH, triple bond CH, we will get the product, write it down. Plus 6 AgCl. 6 AgCl. Put the heading on alkynes, physical properties. Physical properties. Physical properties. Okay. So, like alkanes and alkenes, same alkynes also. First 3 members are, write it down. First 3 members are gases. Write it down. First 3 members are gases. First 3 members are gases. Colorless gases and and next 8 members are liquids. Next 8 members are liquids. First 3 are gases, colorless gases, and next 8 are liquids, and above are solids. Above are solids. Smell and rasanta. Smell. All alkynes are odorless. Next, melting and boiling points. Melting and boiling points of alkynes are slightly higher than melting and boiling points of alkynes are slightly higher than those of corresponding alkenes and alkanes. Corresponding alkenes and alkanes because of linear structure. Because alkynes are triple bond sp hybridization, right? Because of the sp hybridization they are linear. So because of the linear, the melting and boiling points are slightly higher than the corresponding alkenes and alkanes. So because of linear structure, what exactly happens? Close packing structure is possible. Write it down. Close packing structure is possible. Next, solubility. Alkynes are insoluble in water. Because alkynes are non-polar in nature. I told you same like alkanes, alkenes, alkynes, like dissolves like nana. So polar compounds are soluble in polar solvents and non-polar compounds are soluble in non-polar solvents. Okay, so alkynes are non-polar, so that's why they are not soluble in non-polar solvents. So polar solvents water, but they are soluble in organic solvents. Alkynes are not soluble in water, but they are soluble. Alkynes are soluble in polar solvents. Organic solvents, right? Organic solvents. Right? So these are the physical properties. Next, chemical properties. Chemical properties. So alkynes undergoes electrophilic addition reactions. Now try this product. Everyone. 2 times take 2 moles of beer, HBr. 2 moles of HBr and write the product. Try by your own. Right or wrong doesn't matter. Same like alkenes. 2 times attack it. So first mole what exactly happens? HBr, H plus Br minus, right? So the H plus, for example, this is a symmetrical alkyne, so I'm just attacking over here. What exactly happens? pH, H double bond, pH positive charge. Next, what exactly happens? Br minus, pH H double bond, pH Br. This is first mole. Okay. So next, what about second mole? Second mole is important. pH2 double bond CH Br. So now the H plus is attacking at which position? Let me know. This first position or second position? Imagine I'm just giving the numbering like this. If it is attacks the first position, just here what exactly happens? If it is attacks the first position, CH2H, CH2 Br positive charge. It's at if it attacks the second position. If it attacks the first position, CH2 plus CH2Br. Now two carbocations are forming. So which one is this is first one, this is second one. Which is more stable? Let me know. Which carbocation is more stable? First one or second one? Here is first one is more stable, Nana. Because heteroatom and because we can say the resonance and all. So first one is more stable. So then second Br minus is coming and attacking this particular one. This will be the major one. Not CH2 here, CH. So this is the major product. 1,1 dibromo ethane. Write it down. Clear? Anybody having any doubt? Now try this product. Everyone. 2 moles of HBr. Come on, Nana. Write it down. Same like that model. So first H plus is coming and attacking over here, Nana. Right? Then CH3, C triple double bond, it is positive charge, CH, H. So then Br minus, CH3, CBr, double bond CH2. This is the first mole. Okay? Second mole. Once again, H plus coming and attacking over here. CH2H cause positive charge. So then Br minus CH3 CBr Br CH3 2,2 dibromo propane. Write it down. So the reactivity order, Nana. The reactivity order HI is greater than HBr, then HCl. HF won't participate because that is highly exothermic reaction. Next, reaction with HOCl. Reaction with HOCl. HOCl, right? Here is right, take 1 mole. Only 1 mole. So HO minus Cl plus exactly. Okay? HO minus Cl plus. Try this. For example, CH, it is Cl double bond CH OH, Nana. Enol form. So can we write ketone form? Hello? C double bond O H. Keto-enol tautomerism, do you know? Hello. 1 mole. Clear, everyone? If you are taking the 2 moles, what exactly happens? So first mole CHCl double bond CH OH, first mole. So because HOCl undergoes HO minus Cl plus. Next, if second mole, if you are adding, what exactly happens? Let me know. HOCl. Hello. Okay. Yes or no? So 2 OH groups on the same carbon, is it stable? It's unstable, it's losing water molecule. So we'll get CH, it is Cl2, C double bond OH. Come on, write down 1 mole product and 2 mole products. Both are important. Write it down now. CH3, C triple bond CH, HOCl. 2 moles తీసుకుంటాం. 2 moles of HOCl. Come on, write the products. HOBr. In electrophilic addition reactions, alkenes are more reactive than alkynes. Alkenes are more reactive than alkynes. In which reaction? In electrophilic addition reactions. In electrophilic addition reactions, alkenes are more reactive than alkynes. What exactly the product here we will get? CH3, COH, OH, CH, Cl2. But 2 OHs are at the same carbon. What happens? It loses the water molecule. What exactly happens? CH3, C double bond O, CH, Cl2. ఈ H ప్లస్ ఈ OH వెళ్ళిపోతారు, మైనస్ వాటర్. ఇక్కడ కూడా అంతే సేమ్. CH3, C double bond O, CH, Br2. So these reactions I already explained. CH triple bond C, CH to CH double bond CH2. Okay? Plus HBr. Only 1 mole. 1 mole. Right, let me know. So here is alkenes and alkynes both are there. Which reactions takes place? Which one will react? Alkenes, no. Okay. In this case, alkenes are more reactive because in the electrophilic addition reaction, alkenes are more reactive than alkynes. CBr, CH double bond CH2. So this is the exceptional case because of the forming product is more stable. More stable product form avutundi kabatti. So in this case, alkyne, right? The HBr will attack at the alkyne. Write it. Addition of water. Next. The addition of water takes place in presence of H2SO4, HgSO4. H2SO4, HgSO4. Right. So what exactly happens here? H plus plus OH minus, first H is attacking double bond CH, OH nano. So the first step this is. Once again we can see here is what exactly happens here? Which form it is? Enol form. So when the enol form is coming, so you can write keto form. CH3, C double bond O, H. Aldehydes we will get now. In this case, aldehydes we will get. H2SO4, HgSO4, let me know. So here what is the product? CH3, COH here, double bond, CH2. Okay. Now this is enol form. Ketone form, if it is converting, CH3, C double bond O, CH3. Acetone, or we could say the propanone. Propanone or acetone. So ketoenol tautomerism, of course, you people know, right? Next, Nana, addition of X2. For example, CH triple bond CH, X2, friends of CCl4. If you are taking the 2 moles, Nana, take 2 moles. Otherwise, directly I am writing here as 2 moles. C, CH, CH, Cl, 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 Cl. Tetrachloro lawsum. For example, CH3, CH, C triple bond CH3. So only one mole of chlorine. If you are using the 1 mole of chlorine, we'll get trans product. We'll get trans product. Come on, write it down. Control reduction. This is important, and recently JEE Mains they asked this question. Lindlards and Birch reduction. So when we are doing the reduction in presence of hydrogen palladium BaSO4. This is Lindlards. So Lindlards catalyst. So if you are using sodium in presence of liquid ammonia, this reaction we call as Birch reduction. So very important, 5-star bit. Compulsory, they'll ask the question once again, right? So in this case, palladium presence of barium sulfate will get this alkene. So reaction will stop at cis alkene is forming here. In this case, Nana, you get trans alkene. Trans alkene. So palladium presence of barium sulfate, what exactly happened? The 2 hydrogens will attack from the same side. So it's no need, actually it is no mechanism, but in this case we had the mechanism. I'll let you know. And without mechanism, how can we identify these two? If hydrogen in presence of palladium barium sulfate, దీంట్లో ఇక్కడ నైట్రోజన్ ఉందా? ఇక్కడ ఉంది కదరా. నైట్రోజన్ ఎలా ఉంటున్నాను? అమ్మోనియాలో నైట్రోజన్ opposite direction, nothing but trans. Get trans. So we'll see this Birch reduction mechanism. CH3 C triple bond C CH3, right? So generally sodium undergoes Na plus electron. So here, right, it undergoes homolytic cleavage like this. So here is CH3, C double bond C, CH3, radical, and one radical is coming from the sodium. So one electron is coming from the sodium, it becomes CH3, C, negative charge, two electrons. Okay. So automatically lone pair repulsions are more than lone pair bond pair and bond pair. So by default I am just writing like this. Here is one and here is one more electron like this. So what exactly happened? Ammonia, NH3, liquid ammonia we are using, right? That giving the proton CH3 H here, double bond. So electron CH3, once again one more electron is coming from sodium. CH3CH, double bond, here is the lone pair. So then once again ammonia, NH3. Actually mechanism is not needed, we need to know just simply either the product is cis or trans, okay? Because of lone pair repulsions, both are in the opposite direction. That's the reason we'll get the trans product. Okay, just write it down. So mainly focus on this reaction. This and trans, very important. Next, reaction with Grignard reagent. Reaction with Grignard reagent. RMGX. CH triple bond CH plus RMGX. What would be the product, Nana? CH3 MgBr, for example. What is the product? It is R minus MgX plus, right? This is acidic nature because of sp hybridization. So we'll get alkane plus CH triple bond C minus MgX plus. In this case, no, CH4 plus CH triple bond C minus MgBr plus. So I told you Grignard reagent in case of preparation of alkanes. What I told? Hello. So write it down, one more product. Come on, write the product. So here is CH3, ethane. Ethane. In this case, no reaction. Why? Why? No alkane is forming. Why, Ram? Because no acidic hydrogen. The hydrogen is directly attached with the triple bond carbon, that only so those will give, but not this one. RMGX, RMGX reactions, RMGX plus any proton donor will get alkanes, right? R minus here, proton donor means H plus, right? Will get RH. What are the proton donors? Let me know the list. Water is a proton donor. Okay. RMGX with water, so we'll get an alkane. Next, Nana. This acetylene. Right? This also will give, but not, hello, but not this one, because there is no acidic hydrogen. Got it? And anything else, let me know. Proton donors. Alcohols. You can take phenol, carboxylic acids and benzoic acid, RNH2 amines, secondary amines. So eighth one, pyridine. Any proton donor, ATC. So we'll get alkanes, right? Write it down. And very important, in the preparation of alkanes, we will use this. Next, alkyne, when terminal alkyne, if there CH3 triple bond H, when it's treating with sodium metal, like otherwise NaNH2. Otherwise, we can use RMGX. Otherwise, we can use RLI. RLI. So what exactly happens? R C triple bond C minus Na plus nana. Because acidic hydrogen must be present. Then here is also same. R C triple bond minus Na plus. Here is RH. This is from, and remaining product is same, we know. RC triple bond C minus MgX plus. Here is also alkane plus RC triple bond C minus Li plus. Right? So this, it won't react with strong like this, right? NaOH and NaHSO3, Na2CO3. No reaction. No reaction. Write it down. This is no reaction. Simply acidic hydrogen should be present, then only the reactions are takes place. This metal is replacing with the hydrogen, nothing is there. Okay. Reaction with Tollens reagent. Tollens reagent. So what is that Tollens reagent? Ammonical, right? AgNH3 taken twice positive. Nana. So in this case, Nana, two acidic hydrogens are there. So two places, what exactly happens? Hello. Ag with Ag plus Cl minus like this. Triple bond C minus Ag. For example, R C triple bond CH. Same. What exactly happened? R C triple bond C Ag. For example, R C triple bond. In this case, no reaction. Why? Why no reaction in this case? No acidic hydrogen. Write it down. Good. This is like white PPT. White PPT is formed. Next one, cyclic polymerization. One more reaction. Cyclic polymerization. This is very, very important. What is polymerization? Right, 3 moles if I am taking, when we are, right, red hot iron tube. Red hot iron tube. If you are passing this acetylene gas, red hot iron tube, what exactly happens? So this bond is coming over here, this bond is coming over here, this bond is coming over here. You will get a benzene. Come on, write it down. Very, very important. From aliphatic to aromatic, this is one of the important reaction. And from alkanes, an hexane, Al2O3, Cr2O3 or V2O5 or MO2O3, also we got that same. Write it down. Somewhat higher temperature, 873 Kelvin something. If you are attaching one methyl group, same. Three methyl groups will come in.